Hey students, today we are doing the May June paper 6 variant 1 of the year 2024. Let's start this paper. Question number 1, a student carries out a titration to find the concentration of a sample of dilute hydrochloric acid. So a student is doing titration. Titration is when an acid reacts with an alkali to form salt and water. And when we do this neutralization, this is a neutralization reaction. And when we do this neutralization reaction in the laboratory in practical way to find out that how much volume of an acid is used to neutralize the known volume of alkali, we do. This is called titration. So we want to find that how much concentration of hydrochloric acid is needed to neutralize potassium hydroxide, which is 25 centimeter cube. So we have taken a known volume of potassium hydroxide in a flask, then add a few drops of suitable indicator to the apparatus labeled A. We'll add the indicator to make sure that when the solution has been neutralized. So indicator tells us that when the solution is neutralized by changing the color. Number 2, we will use burette to add dilute hydrochloric acid to aqueous potassium hydroxide and indicator mixture in the apparatus labeled A. Okay, now the question is, name the items of apparatus labeled A and B. So what is A? It's a conical flask. What is B? It's a pipette. So we'll write it's a volumetric pipette. Next part, student adds the indicator after the volume of the 25 centimeter cube of aqueous potassium hydroxide has been measured. Explain why the student adds an indicator to the aqueous potassium hydroxide. So why do we add indicator solution? As I said before, that indicator indicates that when the solution turns to a neutral by changing its color. So why do we add indicator? So that it can change the color at endpoint. And the endpoint is when the solution has become neutral. That's called endpoint. And the indicator changes its color. Name a suitable indicator. So in the titration, we can use methyl orange, or we can also use thymolphthalein. Describe how the student can determine the volume of dilute hydrochloric acid used in this titration. So we have taken potassium hydroxide in a flask and we add the hydrochloric acid from the top by using a burette. So in the burette, we will take hydrochloric acid and we'll keep on adding hydrochloric acid into the KOH until it becomes neutral. So how we will know that how much volume of hydrochloric acid is used? By taking the initial and final readings. So what we'll do? Take initial and final readings and final volumes, initial and final volumes of hydrochloric acid. And the second point will be that we'll take a difference of final minus initial. So we'll do final minus initial, which gives us the total volume used. The total volume which has been used or taken up by the KOH to become neutral. Last question, the student observes the color change that occur as they add dilute hydrochloric acid from the burette. State one other thing a student should do as they add the dilute hydrochloric acid to the potassium hydroxide. So what should they do? They added the indicator solution and they are adding hydrochloric acid. What should a student do to make sure that they are completely mixed with each other and they react with each other? So a student should swirl the flask. Students should swirl the flask to make sure that all the contents are mixed. All the contents are mixed. All the contents and all the reactants of hydrochloric acid and potassium hydroxide are mixed with each other. Next, we have question number 2. Question number 2 is, a student investigates the temperature change when magnesium reacts with sulfuric acid. So, in this investigation, we have to find out the temperature change, how much the temperature changes when magnesium reacts with sulfuric acid. So if the temperature increases during the reaction, then how much it has increased, and if the temperature decreases, then how much it has decreased. So a student does 5 experiments. Experiment 1 is use a 25 centimeter cube measuring cylinder to pour 20 centimeter cube of sulfuric acid into a boiling tube. So we are adding 20 centimeter cube volume of sulfuric acid. Use a thermometer to measure the initial temperature of the acid. Record the initial temperature. Add a 0.5 centimeter cube length of magnesium ribbon. So we are adding 5 centimeter cube of magnesium ribbon to the acid. Start the timer. Continuously stir the contents of the boiling tube. After 45 minutes, measure the temperature. So we recorded the initial temperature, and after 45 seconds of adding magnesium ribbon, will add the temperature. We'll measure the temperature again. Record the temperature, rinse the boiling tube with distilled water. Then we'll perform the experiment 2, taking the same amount of sulfuric acid, which is 20 centimeter cube. We took the same amount of sulfuric acid, but this time we use a 10 centimeter cube measuring cylinder to add 2 centimeter cube of distilled water. So we added 2 centimeter cube of distilled water also to make it dilute. Rest of the thing is the same, that we added 5 centimeter cube length of magnesium and everything. Everything is the same. That will record the initial temperature and will record the final temperature. The difference in this experiment from the first one is that the student adds 2 centimeter cube of distilled water. In experiment 3, student adds 4 centimeter cube of distilled water. In experiment 4, 6 centimeter cube of distilled water. And experiment 5, 10 centimeter cube of distilled water. Rest of the thing is the same. So we have to complete these tables first. Experiment 1, what is the volume of sulfuric acid used? Now, the volume of sulfuric acid in all of the 5 experiments is 20 centimeter cube. So we'll write 20 centimeter cube in all of the experiments. Centimeter cube. Now we'll see that how much volume of distilled water is added. Then in the first experiment there was no distilled water, so 0 centimeter cube. In the second experiment, it was 2 centimeter cube. Then 4 centimeter cube distilled water is added in the third experiment. In the fourth experiment, 6 centimeter cube. And in the fifth experiment, 10 centimeter cube distilled water is added. The initial temperature is already written, which is 25 for the first experiment, 25.5, 25.5, 26, and 26. These are the initial temperatures. Now, the final temperature after 45 seconds, we have to note down from these thermometer diagrams. For the first one, we can start reading from down. It's 30, 35, 36, and 37. So the first one is 37 degrees Celsius. The second one is 34 degrees Celsius. In the third experiment, the temperature is 31.5 degrees Celsius. In the fourth experiment is 30.0 degrees Celsius. And in the fifth experiment, it's 27.5 degrees Celsius. Note that we have to write the values in one decimal place. So here also, we'll write 37.0 degrees Celsius and 34.0 degrees Celsius. Now we have to see the difference between them. Temperature increase will do initial, final minus initial. So 37 minus 25, it's 12.0. 34 minus 25.5, it will be 8.5. 31.5 minus 25.5, it is 6.0. 30 degrees Celsius minus 26 degrees Celsius, it will be 4. The difference is 4. And 27.5 minus 26, it will be 1.5. State which experiment 1 to 5 had the smallest temperature change. Now, for the smallest temperature change, as we can see, the temperature change 12, 8.5, 6.0, 4, and 1.5. So the smallest temperature change is in experiment 5. Explain why the temperature change was smallest in the experiment you have given in B1. Because in this experiment, the largest volume is heated. Largest volume we have taken because here we have added 20 centimeter cube of sulfuric acid and 10 centimeter cube of distilled water. So here the volume is the maximum. That's why if we have largest volume, so the temperature change between them will be least because the volume is more. We have taken more solution. As we see in the others, the volume is the difference between the total volume is less. In experiment 1, it's 20. In experiment 2, it's 22. In experiment 3, it's 24. And in experiment 4, it's 26. The total volume. And in this one, it's 30. So in experiment in experiment 5, why there is a smallest temperature change? Because there is a largest volume taken in experiment 5. Draw a suitable scale on the x-axis and plot your results from experiments 1 to 5 on figure 2.1. Draw a line of best fit. Now we have to plot the graph. The volume of distilled water is already, the scale of x-axis is already taken. 0, 2, 4, 6, 8, 10, 12. Now we have to take the y-axis scale with the increase in temperature. As we can see, the increase in temperature starts from 1.5 and it is going till 12. So what we can do, we'll take the boxes like 2, 4, 2.0, 4.0, 6.0, 8.0, 10.0, and the last one is 12.0. We can take the scale like this. Now we'll plot the graph. As for the first one, we added 0 distilled water and the temperature change is 12. So at 0, it is 12. We'll use a cross. We have to use a cross always to make a graph, to make points. Then at 2 centimeter distilled water, 8.5. 8.5. Here we have 9.0. So 8.5 will be somewhere in the middle here. Then with 4 centimeter cube, we have 6 difference. With 4, we have 6. Here you go. With 6, it's 4. So with 6, at 6 volume of distilled water, we have a difference of temperature 4. Then at 10, we have 1.5. At 10, it's here it is 1. So it will be somewhere in the middle here. Now we'll join these points to make a line of best fit. So we'll put a scale to draw the line and just leave any ambiguous points. Okay, so that's how you will draw a line. Use your graph in figure 2.1 to deduce the temperature increase when experiment 2 is repeated with 7.5 centimeter cube of distilled water instead of 2 centimeter cube. So in experiment 2, we have taken 2 centimeter cube of distilled water. So instead of 2, if this experiment is repeated with 7.5 centimeter cube, then what will be the answer? How much uh, uh, temperature change will be there? Show your working on the graph. So for 7.5, here we have 7, and the 7.5 will be somewhere in the middle of it. Okay. And with experiment 2, for the second experiment, we will move it up. For the second experiment, okay. The second experiment. This is a second experiment. Okay. So for the second experiment, we'll take here is 7.5 here in the middle. Okay. Here, and then we'll move backwards. Okay, and our point is coming somewhere here, so it will be 2.8 or 2.9. So you have to show your workings like this, and you have to write the answer on the graph also. So it's 2.8. So we'll write the answer, 2.8 degrees Celsius. Then the next question is the average rate of temperature increase in each experiment is calculated using the equation shown. Average rate, to find the rate, we have the formula temperature increase divided by time taken. Calculate the average rate of temperature increase in experiment 1. So in experiment 1, the temperature increase divided by 45. So divide by 45, the temperature increase in experiment 1 was 12. So we'll write it here. It's 12. So 12 divided by 45, it's 0.27. 0.27, and the units will be, because the temperature change is in degrees Celsius and the time is in seconds. So we'll write the unit will be degrees Celsius over seconds. Explain why the results of the experiment are more accurate if the boiling tube was wrapped in cotton wool. Cotton is an insulator, and we are measuring the temperature change here. So to avoid the heat loss, we will use a boiling tube wrapped in a cotton wool. So first, because a cotton wool is insulator and it reduces the heat loss. Also, the temperature change would be more accurate. You can write any 2 points from these three. Explain why a 25 centimeter cube volumetric pipette cannot be used to accurately measure the volume of distilled water added. As we can see, the added distilled water is continuously changed because previously in experiment 2, we add 2 centimeter cube of water. In the next experiment, we add 4 centimeter cube of water. In the next experiment, we add 6 centimeter cube of water. And in the fifth experiment, we added 10 centimeter cube of water. So the water water volume is continuously changing. So for the changing volume, we cannot use pipette for that. So we can write that the volume is not fixed. We use pipette for the fixed volume, to measure the fixed volume. State one other way in which the apparatus can be changed to give more accurate results. So we can use a burette instead of measuring cylinder to pour distilled water. Instead of measuring cylinder to add distilled water. Next, sketch on figure the graph you would expect if all of the experiments were repeated using a 2 centimeter cube length of magnesium ribbon instead of 5 centimeter cube length. So now we are decreasing the quantity of magnesium ribbon. So magnesium ribbon was taken 5 centimeter cube. Now we'll repeat the experiment using 2 centimeter cube of magnesium ribbon. So obviously there will be less heat loss because the substance is small now. So heat loss, increase in temperature will be less. So the line will be, all the points will be a little bit down. So it will be like this. And we'll label it as question G.